Okay, so today we're going to switch gears just a little bit. We're continuing rational. There's only really one more topic. Instead of simplifying rational expressions, we did things like add, subtract, multiply, divide. What we're going to switch gears now is solving rational equations. So if you'll notice, everything we did before was just an expression. What's your clue that it's an equation? It has an equal sign. If you see an equal sign, you are no longer just factoring and simplifying. You are asked to come up with a solution. Okay? So when we saw something like this, that's just an expression. We were asked to add those expressions together, which meant we need to get a common denominator. We found the common denominator, we added this together, and we came up with an expression like this. Okay? Now we're switching gears and we're going to solve rational equations, so we need to have those expertise that we had of multiplying, adding, subtracting to come up with a solution for an equation. The other skill that really is handy for solving is knowing what an exclusion is. So it may have felt like I just made you do that as a trivial exercise, but it has real applications here when we're doing this. So first of all, what are the exclusions here in this equation? X cannot be what? Yeah, X cannot be 0 or -1. Okay. Now, what I can do to solve this equation, I can get a common denominator, but what I can do here, one thing's real simple, is I can multiply both sides of this equation by the common denominator. And that's something that would do something for me, like clear the denominator. So what I'm going to do, what is the common denominator here? What's the common denominator, guys? It's x times x plus 1. So I've got this equation 2 over x equal 3 over x plus 1. So I'm going to multiply by my common denominator. So what is my common denominator? X times x plus 1 and x times x plus 1. Now I didn't write, remember before when I was adding and I was getting a common denominator, I would multiply by x over x, okay? Now that I've got an equation, what I did, I multiplied by this equation on both sides by the same thing, okay? So I haven't violated any rules. I've multiplied both sides of this equation by the common denominator. So what is x over x? That's 1. What is x plus 1 over x plus 1? That is 1. So what do I have? I've got 2 times x plus 1 equal 3x. What kind of equation is that? Starts with an L. Linear. Those are the easy ones. Those are the algebra 1 equations. So this is 2x plus 2 equal 3x. How do I solve that? So what? Yeah, I want to get all my x's on one side, all my numbers on the other side. So I look at it and I say, I try to not deal with negatives if I can. Let's subtract 2x from both sides. So when I do that, I get 2 is equal to x. So this tells me that x equal 2. And what you always have to check and see, does that violate my exclusions? What can x not be? Cannot be 0, cannot be -1. Is it okay for it to be 2? Yes, okay, we're good. Now the other thing you should notice is, in middle school, how did you solve something that looked like fraction equal fraction? You were taught to do what? Cross multiply, okay? Multiplying both sides by the common denominator is the same as cross multiplying. 2 times x plus 1 equal 3 times x. That's what we have right here. 2 times x plus 1 equal 3 times x. So anytime you have fraction equal fraction, you can just cross multiply. And that, in effect, is the same thing as multiplying both sides by the common denominator. So some people find this easier. So that's 2 times x plus 1 equal 3x. And that was the same step I got to right here. Okay? So I can save a little bit of trouble by, if I multiply both sides by the common denominator, that cancels the denominator on both sides. But in effect, all I'm doing is just cross multiplying. You see how that works out? So anytime you have fraction equal fraction, you can cross multiply. So let's look at the example here. I've got a rational equation. It's in the form of a fraction equal fraction, which means how can I solve it? I can solve it by cross multiplying. So first of all, what are the exclusions? Yeah, x cannot be what? -1. And if you can't do that off the top of your head, what would make 4x plus 5 equal 0? 4x would have to equal -5. X would have to equal -5 fourths. Okay? So my exclusions are -1, -5 fourths. So I know that x can never be -1 or -5 fourths. Okay? So now when I cross multiply, I get 3 times 4x plus 5 equal 9 times x plus 1. Okay? What kind of equation is this? Starts with an L. It's linear, okay? This is pretty straightforward. This means just don't make mistakes. So 12x plus 15 equal 9x plus 9. Okay? If I subtract 9x from both sides, I get 3x plus 15 equal 9. If I subtract 15 from both sides, I get 3x equal, what is it, -6. So x is equal to what? Yeah, -2. Does that violate either of my exclusions? No. So this answer is good. How do you know this answer is correct? You can do what? Pardon me? Yeah, plug it back in the original answer. So if I'm concerned, did I get the right answer or not, we can do that. So I don't require that, but you can check your answer by just plugging in -2 in the original. So 3 over -2 plus 1 equal 9 over 4 -2 plus 5. So what's -2 plus 1? -2 plus 1 is -1. So 3 over -1, that's -3. And this is 9 over, what's -8 plus 5? -3. So does -3 equal -3? Yes. Okay. So that tells me that this is the correct answer. Okay. Now here we switch gears, make it a little bit harder. Do I have fraction equal fraction here? No. Why do I not? When I say fraction equal fraction, that's when I cross multiply. That was the one you saw here. Here I don't have fraction equal fraction. I have fraction plus fraction equal fraction. What do you think I'm going to have to do? Pardon me? Yeah, so, well, on the side that has fraction plus fraction, what do you think I'm going to do? I'm just going to add them together, and then I will get fraction equal fraction, okay? So look at the left side. What is the common denominator? Yeah, x times x minus 2. So this is 10 over x minus 2, plus 4 over x. And what do I multiply 4 over x by? Yeah, x minus 2, x minus 2. And all of that equals 5 over x minus 2. So now I can add all of these things together. So this is going to be 10 plus 4x minus 8 over x minus 2 equal 5 over x minus 2. So this is what, 2 plus 4x over x times x minus 2 equal 5 over x minus 2. So now, do I have fraction equal fraction? Yeah. So now what I can do is just a couple of things. I can multiply both sides by the common denominator, or I could cross multiply, either way. Okay. This one looks a little bit more complicated. When I get something like this, it's got two terms. rather than cross multiply, I may just multiply both sides by the common denominator. You're going to get the same answer, but I'll just write the step here. I'm going to multiply by the common denominator. So when I do that, I'm going to have 2 plus 4x over x minus 2. So I'm multiplying by the common denominator on the left, and then I'm going to multiply by the common denominator on the right. Multiplying them by the common denominator is pretty cool because what does it usually do for you in this problem? It makes it a lot easier to simplify because you've got x over x, x minus 2 over x minus 2, x minus 2 over x minus 2. This problem becomes what? 2 plus 4x equal 5x. That's a much easier problem. And then what do I do to solve this guy? Subtract 4x from both sides, and you get 2 is equal to x. Now, one thing I did not do. What did I not do at the start of this problem? The exclusions. What are the exclusions? The exclusions are x cannot be what? 0 or 2. But we've got a problem now. What? Yeah, so how do I reconcile this? I know that x can't be 0 or 2, but when I solved it, I came up with x equal 2. Which of those things wins? The exclusion or the solution? The exclusion. X cannot be 2. So if you think x is 2, if you think x is equal to 2, you are wrong. It cannot happen, okay? So this thing has no solution, okay? Okay? So this is one of those cases where you started out with a problem that looks like this. By doing things that are perfectly fine and legal, multiplying both sides of an equation by the same thing, you came up with a linear equation that had a solution. So yeah, x equal 2 is the solution to that equation right there. It will always work. It's no exclusion. So x equal 2 solves this equation, but it will not solve the original equation. So these are called extraneous solutions. We've seen them before when we squared both sides of an equation when we were dealing with those solutions. So you always want to be in the habit of finding your exclusions, find your answer, and if your answer violates the exclusion is going to take priority on this. Yeah, so this one has no solution. So let's look at this one. I've got the form fraction equal fraction. What can I do here? I can just cross multiply here. So I'm going to have 7 times 2x minus 10 equal 11 times x minus 2. Now, before I go too far, what are my exclusions here? And this is where, in a problem like this, I may not ask you for the exclusions, but it's incumbent upon you to find them because they affect your answer. So x cannot be what? 2 or what? 5. So x cannot be 2 or 5 because that would make this problem divide by 0. So now let's multiply this out and see what our answer is. This is 14x minus 70 equal 11x minus 22. If I subtract 11x from both sides, I get 3x. If I add 70 to both sides, so 70 minus 22 is what, 48? This tells me that x equals what? 16. So does this violate either of my exclusions? No. How do I check my answer? Hey, you can plug it in. 7 over 16 minus 2. What's 16 minus 2? 14. What's 7 over 14? 1/2. That's the left side. Plug it in the right. What's 2 times 16? 32. 32 minus 10 is 22. 11 over 22 is 1/2. So we did the correct math to get this solution. Okay, what do we do here? Do we have fraction equal fraction? We do, okay? You want to be careful. What are we seeing here that we want to be careful about? The negative sign. So when I see that, it's got to go somewhere, okay? If I put it on top, that makes that a -4. If I put the negative on the bottom, x plus 3 becomes what? What's the negative of x plus 3? Negative x minus 3. That feels like more work. Where do you think I'm going to put the negative? On the top. So I'm going to write this as -4 over x plus 3 equal 5 over x minus 3. You're going to have to deal with a negative at some point anyway. But so now I cross multiply. So this is -4 times x minus 3 equal 5 times x plus 3. What are my exclusions? X cannot be plus or minus 3. Okay. So what is -4? This is -4x, what? Plus 12 equal 5x plus 15. If I add 4x to both sides, this becomes 9x. If I subtract 15 from both sides, this is what? -3. So -3 equal 9x. Therefore, x is equal to what? -3 over 9, or x is equal to -1/3. Does that violate my exclusions? No, because x cannot be plus or minus 3. Okay, what do we see here? Yeah, here we have to factor, okay? So the one that has to be factored is the quadratic. So are there two numbers that multiply to -10 and add to -3? Yeah, so 5 and 2. 5 and 2, if the 5 were negative, those numbers multiply to -10, add to -3. So this problem is 3 over x minus 5, x plus 2 equal 4 over x minus 5. What are my exclusions here? X cannot be what? 5 or -2. Okay, now I've got it in the form fraction equal fraction, so I can do one of two things. I can multiply both sides by the common denominator, or I can cross multiply. What do you want to do? Cross multiply. So it's going to be 3 times x minus 5 equal 4 times x minus 5 x plus 2. Now there's something that there's a long way or a short way here. What do you want to do? It's a short way, okay? I mean, what do I do with this x minus 5 on both sides? Pardon me? Right, it can cancel out, okay? Because, I mean, you could divide both sides by x minus 5. So this is one of those cases where sometimes when you cross multiply and you don't see that, you're adding some extra work for yourself. So that's going to cancel. This is just 3 equal 4 times x plus 2. So 3 is equal to what? 4x plus 8. So if I subtract 8 from both sides, I get -5 equal 4x, and therefore x is equal to -5/4. Okay. So what I tend to do when I've got a denominator that's more complicated like this, or has repeated factors, the other alternate thing to do, like I said, is just to multiply both sides by the common denominator. So 3 over x minus 5, x plus 2. If I multiply that by the common denominator is x minus 5, x plus 2. So if I just multiply both sides by that, and then I get 4 over x minus 5 times x minus 5, x plus 2. So if I multiply both sides by the common denominator, I'm not adding them together with a common denominator, just multiplying both sides of the equation by the same thing. That allows this to cancel, this, this, and this, and I get 3 is equal to 4 times x plus 2, which is the same thing I had when I was right here. Okay, so there are two ways of doing that. You can, to clear out fractions, multiply both sides of an equation by the common denominator. In effect, it's the same thing as cross multiplying, but you may have other simplification that comes along when you do that. Let's work one more since we've got some time, just so you can see something. Say 1 over x plus 1 over x plus 2 equal 3 over x. Now, do those things share the same denominator? No, I can't really add them all together. Do any of them share a denominator? Which ones? Yeah, so what would happen if I did this? Let's subtract 1 over x from both sides. What's 1 over x minus 1 over x? 0. So this becomes 1 over x plus 2. What is 3 over x minus 1 over x? 2 over x. Which equation looks easier, this one in blue or this one in green? Yeah, so you can sometimes make these problems a lot easier if two things will combine, to combine them, because now how can I solve this? I can cross multiply. This means that x is equal to 2 times x plus 2. X is equal to 2x plus 4, which means minus x equal 4, or x equal negative 4. What were my exclusions? X cannot be 0 or negative 2. So I'm okay with that. Okay? So that's another trick, that when you see things like this, the harder way of doing this would be to find a common denominator and add these two things together on the left side. So sometimes it's easier to say, you know, if I've got two things that have a common denominator, let's combine them, make this an easier problem to solve at that point. Okay?